Hey everybody, how's it going? My name is Harrison Hunter, and today on my channel we're going to be continuing our angles and talk about how acute, obtuse, right, and straight angles interact with each other to make shapes. Now, these angles in a previous video, yesterday's video to be exact, we talked about the four angles and what degree they are and how they why are they called what they're called, and we are going to continue that by learning the interaction. But before that, please take a moment and subscribe to my YouTube channel. Hit the little notification bell on the right to get daily notifications of all my videos. And tell the people who need the help. People help the people. And without further ado, let's get started. As you can see, had a little bit of an action, but that's not going to affect our mathematical abilities. So, remember that an acute, obtuse, right, and straight. Let's just go over and find the definition of each of these angles. Acute angle means the angle of this angle here, or the degree of the angle. Oh my goodness. The measurement of degrees in this angle, for this angle, is going to be less than 90. Because 90 is upright, and anything to the right of upright is less than 90. Obtuse is the opposite. Obtuse is anything that is more than 90. So 91 degrees, 92 degrees, 93 degrees, 90.0001 degrees is considered obtuse, believe it or not. And right angles are just, right angles are just at a solid 90-degree angle. This is exactly 90 degrees. And straight angles are basically, well, it's kind of ironic because straight angles don't have any angles. There's just a flat line that is measured at 180 degrees. Because if you pinch 3 points together and you meet it at the top, you get a triangle. And triangles always add up to 180 degrees. So now we're going to learn the interaction between these. What do I mean by interaction? Well, interaction really is if I put a right angle and a straight angle together, what kind of shape would I get, Well, that's pretty easy. So I'm going to use this right angle here, and I'm going to represent the straight angle using dotted lines. So if we just take, well, these 2 points are going to have to be connected to be a shape, right? So we take a straight angle, and we just connect it here. Oops. Boom, we get a right triangle. Now, a right triangle is called a right triangle because, well, it has a right angle. And a right angle is a right angle because it adds up to 90 degrees. Now, if we took the measurements for each of these, this would be a 45-degree angle, a 45-degree angle, and a 90-degree angle. You add those three numbers up and you get 180 degrees. That's just for the straight angle and a right angle. Now let's see what would we get if we added two obtuse angles together. Well, if we look here, let me just use the black marker. So if we use two obtuse angles together, we're gonna get, so look, okay, so obtuse, right? It's more than 90 degrees. So what are we gonna do? We're gonna come like this, meet this guy halfway, and continue down like that. That will give us a parallelogram. Because two obtuse angles, essentially, look, this is what I mean. You take a normal square, right? Take a normal square, and you take these two angles here and just slant them. Boom. Thus slanting the rest of the angles, which gives you a parallelogram, which means essentially you got two obtuse angles and two acute angles, because these acute angles right here cannot be obtuse. So these two acute angles, and we got these two obtuse angles. All right. Now, that's just with two obtuse angles put together. What about two acute angles? Two acute angles will get you the same thing. Because look, this is coming up like that, so we're just gonna continue down. Oh my god, let me make this line a bit straighter. I wasn't thinking straight, therefore it wasn't straight. Okay. Oops. Alright, that's good. Alright, so look, acute angle coming together with another acute angle, right? That angle's acute, gives us the same thing here, except just flipped over. Now look, acute angle, this is obtuse. Obtuse angle, obtuse angle. Feel me? So look, that's what two obtuses and two acutes. Now really you can't add acute and a two obtuse together because it wouldn't really match up. You'd have to draw lines and you wouldn't get a parallelogram. You get a weird little funky shape. But here we can see that if you add two obtuse or two acutes together, you get not only two obtuse angles, but you also get two acute angles. Now, talking with right angles, you won't really get that because you're always gonna get some sort of rectangle. Now I said rectangle, but it can be square. But remember, squares can be rectangles, but rectangles can't be. Oh my goodness, squares can be rectangles, but rectangles can be squares, right? So we take another right angle, and we just bring this bad boy across like that. Okay, boom. You have a perfect square or rectangle. Mathematically, you could call this a rectangle and not have to worry about anything. But really, if you look at it, this side's longer than this side. It's a rectangle. So or if they're the same, they're a square. It's really not that hard to distinguish the two. Now, with this straight angles, you can't just put two lines together because you won't get a shape. You just get a line, right? So what do? You take some sort of three sides and you just pinch them together. This would come up to here, right? So we have a little shape right here, and this stays here, but then this would come up to here, right? And this stays here. And then essentially what you do is you just bend this over here, and you get some sort of triangle, which looks like this. And you get a right triangle. Or you could get an isosceles triangle. Now, why you can call it an isosceles? Because if this adds up to 180 and you take 3 points, 1, 2, and 3, basically you're getting isosceles because all the angles in an isosceles triangle add up to 60 degrees. Therefore, theoretically, giving you a perfect isosceles triangle with just a straight line. And you can do that with any shape. It's like, you know those pipe cleaners you got in kindergarten and you had to make stuff with it? If you got a straight pipe cleaner, right? And you took 2 points and you just pished it together, right? You get a triangle, or if you did 4 points, you could get a square, or if you did 6 points, you could get an hexagon, and that's really it. Well, guys and girls, thanks for watching. This has been a video on interaction between all 4 types of angles. If you liked this video, give it a thumbs up. If you liked it again, go ahead and subscribe. If you didn't like it, still give it a thumbs up. But until next time, I'm Harutsun Harayan from Easy Math. Keep on learning, kids.